Ancient history refined. Scientific tools lead to new discoveries and synchronizing of historical chronologies. Author Doug Walling. Okay. Now we're going to get into the magnetosphere and C14 dating. All right. Let's start with the properties of an atom. I'm going to start with the very basics here. In 1911, Ernest Rutherford discovered that at the core of every atom is a nucleus. Atomic nuclei consists of electrically positive protons and electrically neutral neutrons. These are held together by the strongest known fundamental force called the strong force. The nucleus makes up much less than 0.01% of the volume of the atom, but typically contains more than 99.9% of the mass of the atom. Okay? The number of electrons usually matches the number of protons in the nucleus. An individual atom spins about an axis of the nucleus, creating a dipole magnetic force, north-south, north being positive, south being the negative. Because there are millions of atoms in a conducting medium spinning in random directions, they tend to cancel each other out. So the medium itself does not have a dipole magnetic force. However, if all or a portion of the atoms were spinning in the same direction, the medium would produce a dipole magnetic field about the medium with the magnetic moment based on the portion of the atoms that are aligned and the direction of the field lines. Okay, so there's a direction they come out of the South Pole and they go to the North Pole because the North Pole attracts, the South Pole repels. So that's your field lines and the direction that they go in. All right, so here's an artist's rendition of a beryllium atom. Okay, the nucleus with its 4 protons and 5 neutrons is surrounded by a cloud of electrons. Okay, because what we're looking at here is an inner and outer sphere where these electrons are revolving around the nucleus. Okay, and they are held at a radius. Okay, they're held at a radius from the center of the nucleus to the outer part of each of the spheres. So what you're looking at are not scattered electrons ranging between the outer and inner sections. These are actually all in the same radius, but because it's a sphere, you can see the ones on the other side. So same thing with the outer sphere here of electrons. So there you have your proton and your neutron nucleus, and then you have your inner and outer radiuses for your electrons. Okay, let's take a look now at the properties of electromagnetic forces. What is an electrical charge? All physical objects, wood, metal, water, gas, and people have electrical charges, which can be a positive or negative charge. It's where you see static electricity coming from. Atoms are made up of 3 basic elements, neutrons, protons, and electrons, as we just discussed. An atom with more protons than electrons is said to be positively charged. They attract electrons. And an atom with more electrons than protons is said to be negatively charged. They give up electrons freely. For an example, a battery cathode element is positively charged. Atoms with a deficit of electrons, when connected to a source with an overabundance of electrons, all right. So when a circuit is established between the cathode and an anode element that is negatively charged, atoms with an overabundance of electrons, it creates a current flow via electrons moving in a conductive medium such as metal, that's be copper, iron, steel, or liquid, including water, electrolyte, and acids. Okay. Electric charges attract or repel one another with a force inversely proportional to the square of the distance between them. Unlike charges attract, like ones repel. For example, two magnets with the south end of one facing the north end of the other are set at 1 inch apart. They will attract each other with a specific measure of force, but if you move them apart about 2 times that distance, in this case 2 inches, they will attract each other with 1/2 of the original measurement of force, as long as the inherent magnetic moment, the K factor, of each of the magnets remains constant. The magnetic moment is a vector based on the strength and direction of the force, and we'll cover that a little bit later. Properties of electromagnetic forces. All right, so here we have molecules are made up of different atoms that are attached to one another through this. Remember this strong force. Here we have an H2O molecule, and it's made up of an oxygen atom and 2 hydrogen atoms, and that's why it's called H2O molecule. Okay, so a hydrogen atom has 1 proton and 1 electron. That's the simplest atom that we know of. And then, of course, an oxygen atom is made up of 8 protons, 8 electrons, and 8 neutrons. Okay, so that's our oxygen atom. And then, of course, we talked about our H2O molecule here. You have atoms have a nucleus that are made up of protons and neutrons, with electrons spinning around the nucleus in much the same way as the planets orbit the sun. The atoms spin about the axis like a planet does. Okay, spinning around the neutron here. Uh, uh, and the atom spins about the axis like a planet does. However, these electrons out here on the outer spheres here, the atoms spin about the axis like the planet does. However, the electrons may spin in arbitrary directions and planes about the nucleus, and may have singular or multiple circuits at varying radial distances from the nucleus. We talked about that a little earlier. Electrons can be added or removed based on the attraction of the protons in the nucleus, but cannot have less than the minimum required for any specific element, be it hydrogen, iron, cobalt, water, etc. Most conductive mediums have free electrons not attached to any particular molecule. Okay, so here we have that H2O molecule, we have a hydrogen atom, an oxygen atom, and that's that's what makes up the H2O, the water molecule. Okay. So let's talk about magnetic poles. Magnetic poles, or states of polarization at individual points, attract or repel one another in a manner similar to positive and negative charges, and always exist as pairs. Every north pole is yoked to a south pole. Okay, and that's what is referred to as a dipole magnet. It's a north pole, it has a south pole. An electric current inside a wire creates a corresponding circumferential magnetic field outside of the wire. Its direction, clockwise or counterclockwise, depends on the direction of the current flow. So here we have a battery, and we're showing a positive and negative, and we know that it flows from negative to the positive. When you take this nail and you wrap it with a copper wire, and then you connect it to a battery, you get a flow. And that flow creates the flow. The current going through this wire creates a magnetic field. That magnetic field will magnetize the core, and the core will become south and north, have south and north poles depending on which way the current's flowing. So um, the opposite is also true. A current is induced in a loop of wire when it is moved towards or away from a magnetic field, or a magnet is moved towards or away from it. The direction of current depends on that of the movement. So here we have showing a lawnmower, how a lawnmower works under this principle. You have a magnet that's on this flywheel that's rotating. It comes by these coils. It for a moment it uh, causes the current to flow through the wires, just like we're seeing here, which causes current to go out and goes to the spark plug. It jumps that gap. It fires off. It ignites the gas. Okay, and then goes to ground. All right. So this is a principle that's pretty easy concept, and here we can demonstrate this. Again, this is a very simple demonstration we can do by taking a battery, hooking some copper wires through it. The more coils that you have, the stronger that magnetic force will be. Okay, so you can get a magnet by magnetic forces uh, by running current through a wiring system, or you can get current to flow through a wiring system by running a magnet close to it. And it has to be a certain speed to get a certain amount of current to flow. Okay, that's why this is spinning so fast here. Okay, now that we've got the basics down here for the relationship between current flow and magnetism, let's talk a little bit about the dynamo theory. Okay, NASA has no formula for supporting the dynamo theory. Okay, it's not like they don't have a formula they can apply to each of the planets and kind of get a pretty good guesstimate of what the magnetic forces are and their degradation and all that. No formula. So the dynamo theory, as taught in secular sciences, is the ideal that a large dynamo or magnetic field generator exists within the Earth's core. There are three requisites for this dynamo to operate: an electrically conductive fluid medium, kinetic energy provided by planetary rotation, and internal energy source to drive convective motions. Let's talk about the core a little bit. The outer core. So they hypothesize that the core is actually made up of two: an inner core and an outer core. The inner core being solid iron, and the outer core being liquid iron. So the outer core, which is about 1,367 miles thick, is mostly composed of liquid iron and nickel. The nickel iron alloy of the outer core is approximately between 8,132 degrees to 9,932 degrees Fahrenheit, which is almost the actual surface temperature of the sun. With the inner iron core, solid iron core radius at 756 miles, okay, which is what, about 1,500 miles in diameter, okay. So the inner core is under a pressure of about 52 million psi. All that gravity at that point is compressing the inner core. The solid inner core is spinning in the same direction as the Earth. Okay, the inner core spinning eastward at approximately just a little bit greater than 198 miles per hour. That's the inner core, and just a bit faster than the planet. So they're assuming it's spinning just a bit faster than the planet. The planet's surface spinning eastward at about 1,038 miles per hour, while the outer core, this liquid outer core, is spinning in the opposite direction at a much slower rate. In other words, westward at less than 377 miles per hour at midspan. All right, and they're assuming this in order to meet the parameters that they're seeing. They see the South Pole coming out and the flux lines going from south to north, so it has to be spinning in a certain directions to generate that. And so that's where they come up with this ideal here that the outer core is spinning the opposite of the inner core and the spin of the Earth at this time. Of course, they believes, and they don't really give an explanation for a mechanism, but they believe that at present the outer core is slowing down because that's what the actual we can measure the force of the magnetosphere, and they're seeing that it's actually degrading about 10% right now. And so they're hypothesizing that the outer core is slowing down to get ready to reverse. So the North Pole will become the South Pole in regards to the direction of the flux lines, field lines. But we will see that that's just not true. Okay. So it is theorized that the Earth's liquid outer core constantly moves as the planet cools. This continuous motion is presumed to create electric currents as electrons move through the liquid, just like we discussed in our preliminary here, where the heat from radioactive decay is thought to induce the convective motion of the liquid outer core. Through this theoretical process, the energy of the moving fluid is assumed to produce a magnetic field about the Earth and some planets that can be sustained for billions of years. So they got these electrons, they're free electrons, they're in the outer core. The outer core is spinning at a certain rate, and that rate should produce an electrical magnetic field based on the principles that we just saw for the electromagnetic relationship there. This dynamo generator would produce a virtually horizontal sine wave, okay, in the signature of the Gauss strength of the magnetic field, if the theory were true, as the energy decays and then is bumped up with the various strengths of the energy surges. Okay, so we do have the sine wave. You can definitely see the sine wave in this signature of the measured Gauss strength that we can measure, and we've been measuring for our past 186 years. So that it does have this sine wave, but it is definitely not horizontal. Okay. Uh, which it needs to be for a 4.5 billion year old Earth. But there's no way that you can explain why it's decaying so much here lately. In the last 186 years, 10%, uh, based on this theory. So that's why they come up with another theory of why that's happening about it getting ready to reverse polarity. It's because they've seen some reversals in the magnetism of rocks, which we'll get into in a little bit. All right, so taking a look at this, we have the inner core, we have the outer core. The outer core is spinning, and there's electrons that are released into the outer core as the inner core is being melted, let's say, and heated up. So once you heat something from cooler to hotter, the atoms speed up, and they create heat, and they also create free electrons, and it's um, spinning, so it's creating a magnetic force. The magnetic force is coming out south and coming up north. Okay, spinning if it spins on an axis, from the axis. Okay, and here's the inner core, the outer core, the mantle, and the crust. Okay. An article on the MT website comments that the discovery of Mercury's magnetic field, the residual magnetism found in planetesimals, meteors, and moon rocks, has complicated their understanding of dynamo theory. Before 1974, it was thought that Mercury could not generate a magnetic field because of its relatively small diameter and its slow 59-day long rotation. The lack of an atmosphere. However, when Mariner 10 made a flyby of Mercury somewhere around April 1974, it detected a magnetic field that was about 1/100th of the total magnitude of the Earth's magnetic field. So it has a magnetic field, but it's not supposed to, according to the dynamo theory. See, the dynamo theory obviously is two things. It's not predictive, okay, which is a mark against it, and its parameters are not correct because this one has a magnetic field. Mercury has a magnetic field, but it doesn't meet the minimum required parameters. All right. So now let's talk about the creationists. So that was NASA's, that was the secular humanists' ideal theory for the dynamo theory to try to make some sense out of the magnetic field. So let's talk now about the B&H theory and its accurate prediction of the decay factors of planetary magnetospheres fields. So I'm going to introduce a couple folks here. The B&H theory stands for the Barnes and Humphreys. Let's talk a little bit about who they are. Dr. Thomas G. Barnes holds 3 degrees, a BA from Hardin-Simmons University, a master's in physics from Brown University, and an honorary PhD from Hardin-Simmons University as well. All right. In his book, Origin and Destiny of the Earth's Magnetic Field, I think that was written back in the 1960s, Dr. Barnes postulated a theory on the origin and exponential decay factors of the strength of the Earth's magnetic field that aligns with basic physics of electrical current resistance and entropy. Okay. And now we have Dr. Russell Humphreys, who is a nuclear physicist and a geophysicist, who earned an award for excellence for his contributions in light ion fusion target theory from the Sandia National Laboratories in New Mexico. Pretty famous laboratory, actually. They have invented a lot of these quantum physics and other astrological theories and stuff, and proved a lot of things. So he's a very well-established physicist. Okay, so Dr. Humphreys is a creationist that has formulated a model based on Dr. Barnes' calculations regarding the planetary magnetospheres that is very accurate and as predictive as the formulas for gravity and the inverse square laws of the orbits of the planets about the sun. Okay, whereas the dynamo theory is running into all kinds of problems because the parameters aren't being met where there exist magnetospheres. They don't have a formula for it, and it is not predictive at all. Whereas now we have the creationists theories that have formulas that is predictive and that is 100% accurate. So why would we not take Dr. Humphrey's theory serious? It's just amazing how the human mind will we get caught up in the group think, and it just really can fall under these deceptions of the devil and not look at the facts. Dr. Humphreys has extended this theory to help reconcile some of the carbon-14 dating issues, which, when applied to the Wallen biblical timeline, has proven again to be very accurate and predictive. Well, not predictive, but um, proof of concept that we have resulted with an incredible amount of proof of concept. Okay, Dr. Humphreys has also formulated a model for the origin of the universe as opposed to the Big Bang. It's called the white hole cosmology theory, based on the processes espoused in the Bible, basic laws of physics, and general relativity. His model aligns well with the astrophysics science, with little to no ad hoc theories or conflicting opposing physics that the Big Bang is plagued with. Okay, the scriptures describe a process by which God first made all astrological objects as bodies of water, the earth, the sun, moon, stars, with all the physical properties of water, density and motion, including molecular structure, H2O, gravity, orbits, rotation, and magnetospheres. And then he created the solid matters and associated elements, dry land. So in 6 days, God created the earth within a solar system of many, within a galaxy of many, within a grand universe. Based on these scriptures and basic physics, Dr. Russell Humphreys has formulated a calculation regarding the planetary magnetospheres that is very accurate and is as predictive as the formulas for gravity and inverse square laws for the orbits of the planet about the sun, thereby confirming the 6,000-year-old creation and adding another supportive component to the Wallen biblical timeline. So this science is based on a 6,000-year-old creation, not a 7,000, not a 10,000-year-old creation, a 6,000-year-old creation, and it is 100% accurate 100% of the time in every situation that we know of so far. The science behind the assumptions of the 6,000-year-old freely decaying electrical currents circulating in the Earth's core, as advocated by creationist Barnes and Humphreys, the B&H theory, are aligned with both Sir Horace Lamb's 1883 theory and mathematical formula of free electrical currents circulating in a conducting sphere, and evaluations measuring the magnetic strength of the direction of the force by Carl Friedrich Gauss. And that's the strength. That's where this unit comes from when we talk about the strength of a magnet, the Gauss strength. Okay, so the B&H theory is based on two very well-known secular, I don't know if you want to call them secular, just say well-known and well-established scientists that are accepted by secular scientists. Okay, very basic physics calcs. It's just basic physics calcs. Based on this knowledge, the following assumptions were made for the basis of this model. The Earth was created about 6,000 years ago. While yet in the watery state, God created at least a portion of the H2O atomic nuclei with their spins pointed in the same direction. Remember, we talked about the spins of the nuclei are in all kinds of random directions in a substance, so it's not magnetic. However, if you align those spins to go to the same directions, now you could get a magnetic force, thereby creating a magnetic force of the original magnetosphere. All right, so God created at least a portion of the H2O atomic nuclei with their spins pointing in the same direction, thereby creating a magnetic force of the original magnetosphere. All right, once the solids and other elements were created, the alignments would immediately decay back to random order due to natural thermal collisions. However, large electrical currents, billions of amperes, would be generated due to the laws of electricity and magnetism in the planet's interior liquid iron core, reproducing the magnetosphere at a near same strength. So this model assumes the inner core, there's no inner and outer core, it's just a core that is liquid iron, okay? As opposed to the dynamo theory, which has the core is inner core solid and outer core liquid, and the liquid needs to be in motion, because the free electrons, if they're in motion, they create a magnetic field. This one does not. You don't have to have any motion of the inner core. They, according to Gauss's theory, I'm not Gauss, but Lamb's theory, and he's demonstrated it as a proven theory that if you take a sphere that is a conductive sphere and you induce electric currents in it, it will continue to bounce those currents back and forth at a calculated decay rate, what they call entropy, and depending on any of the other materials surrounding that sphere, that magnetic force, you can calculate that. So it's a very simple, basic physics calc, okay? And that's what we're doing. We're applying that to see if that works in this situation, and it does. At this point, the electric currents would continue to move through the spherical liquid iron core, but would start to decay exponentially due to the laws of electric resistance and entropy along a calculated rate with Sir Horace Lamb's formula. Okay. Decaying magnetosphere. The Earth's dipole magnet field, the magnetosphere, MP, it's our acronym for the magnetosphere, has been decaying at approximately 10% over the past 186 years, as taken from direct measurements of the magnetic Gauss strength about the Earth, and the decay rate appears to be on an exponential curve. There is a direct correlation between the strength of the magnetosphere and the freely decaying electrical currents circulated in the Earth's core, as advocated by creationists Barnes and Humphreys. Hence, the magnetic field is decaying congruent with the entropy of the 6,000-year-old free circulating electric currents of the Earth's molten core, congruent with Lamb's formula of free electrical currents circulating in a conductive sphere. Okay, before these records, okay, so we've had records for the last 186 years, and we know that we can see that it has actually decayed 10% in the past 186 years. 10% is huge, major, for a Earth that's supposed to be 4.5 billion years old, and we've actually measured it. Decays 10% in the past 186 years. Right away, we see there's an issue here. All right. Before these records, before 186, these recorded values of the decay of the magnetosphere, science can see patterns in the science of archaeomagnetism. Okay. Dr. Humphrey states, archaeomagnetism is a study of magnetization of bricks, pottery, campfire stones, and other man-related objects studied by archaeologists. Iron oxides in those objects retain a record of the strength and direction of the Earth's magnetic field at the time they last cooled to normal temperatures. Archaeomagnetic data taken worldwide shows that the intensity of the Earth's magnetic field was about 40% greater in 1000 AD than it is today, and that it has declined steadily since then. Okay, so we have two sources here that we can scientifically establish the decay and the decay rate over periods of time, over certain periods of time. Okay, so here's what that looks like. We're looking at a graph here, a chart showing the decay of the magnetosphere from 1835 to 2010. All right, and you can see this column here is showing the years that these measurements were taken. The first one taken in 1835, it was 8.52, actually times 10 to the 22nd joules per Tesla. And here's some conversion factors from Gauss strength to joules per Tesla and all that. So we're looking at it at joules per Tesla. So that's 8.5 times 2 times 10 to the 22nd power joules per Tesla. And then each year we took that measurement and then all the way down to 2010. And at that time it was 7.75 times 10 to the 22nd power joules per Tesla. And here's the sine wave that we were talking about. It's what you should expect out of a dynamic force. All right. So this thing has degraded at 10% over the last 186 years, and that's huge. That just should not be for a dynamo theory applied to a 4.5 billion year old Earth. So you should see the sine wave, and we do, but this should be horizontal. Okay, so this is what that looks like for the measured magnetic moment down through time that we have. This is going to be our control. Okay, the Earth is our control because we have so much data that we can see about the reliability. Because later on you'll see we're going to do apply the B&H theory, the actual calculations that Dr. Humphreys came up with, and see how accurate his formula is and his model is. Okay, so now here's also taken the what we just saw was the graph of the measured strength of the magnetosphere over 186 years. Now here's the graph when you add to that the time for the archaeomagnetic rocks. It takes us back to 4000 BC. At that time, you had about a 21. You had a Gauss strength. I'm sorry, of 12 here, 12 Gauss here. Today, well, here in 1970, it was down to 0.62. So that's from 12 down to 0.62 is quite a loss there. But it is well calculated within a 6,000 years. All right. Anything above 12 gauss, the Earth, you would not be suitable for life on it. Okay. So you can't really go back further than 12 gauss, and this shows a very suitable curve, exponential curve, fitting the creation model perfectly. The B&H theory's accurate predictions of the decay factors of planetary and magnetospheres continues. In 1984, Humphreys took Dr. Brown's theory, hence the term B&H theory, on the exponential decay factors of the strength of the Earth's magnetic field when extrapolated backwards and produced a model for the life cycle of the Earth's magnetosphere. That's what we just looked at. This model was based on the age of the universe, 6,000 years old, as given in the Bible, the planetary masses, the atomic spins of H2O in particular. We got that from the Bible. Which atom would you use? And we used the H2O, and then he used a certain K factor, in most cases 0.25, to apply to the Earth and all the celestial bodies in the solar system. This K factor has to do with how many of the atoms, the H2O atoms, that were in alignment to create the magnetosphere. Remember, we talked about if you get all these spinning in the same direction, it will create that magnetic force. All right. He then modeled several planetary magnetic fields, such as the Sun, the Earth, the Moon, Mercury, Mars, Venus, Jupiter, and Saturn. His model not only accurately calculated the magnetosphere Gauss values congruent with the known values of the Sun, the Earth, the Moon, and other nearby planets, it also predicted what we would find when we got close enough to Uranus in 1986 and Neptune in 1989 via the Voyager 2, and he was precisely correct where NASA's predictions came up wanting. Okay, NASA did not get an accurate prediction, whereas Dr. Humphrey's predictions were virtually 100% accurate. NASA scientists had originally predicted that there would be no magnetic field about Mercury due to its size, its slow rotation, and all that, whereas Dr. Humphrey's model shows that it would have a magnetic field, its original strength, and the approximate strength at any given time, just as it did with Uranus and Neptune's magnetic field. So it also predicted Mercury's magnetic field and its strength. Dr. Humphrey's model accurately predicted Mercury's decay in magnetosphere in 1974 and 75, to the surprise of NASA scientists. They thought there wasn't going to be a field. To the surprise of NASA scientists, a Mariner 10 spacecraft measured Mercury's magnetic moment at 4.8 times 10 to the 27 second Gauss. I don't think that's right. I carried that over. I think that's like 18 or something like that, or so. I'll have to correct that. In 1984, and then in 2008, the Messenger flew by Mercury and again found the magnetic moment had decayed as the model had predicted. So Dr. Humphrey's formula for the Earth's magnetic moment at a time after creation, we're just gonna take a random time, say 1980, where the Earth's magnetic moment at creation equals this. This was pre-calculated. These are given actually in well, you can calculate them if you want. We have the formulas, but they are also given already calculated for all the hot Jupiters. Well, actually all the planets actually, not just the hot Jupiters. A hot Jupiter, it just means it's a planet with a protective magnetosphere on it. So here it is, the Earth's magnetic moment at 1980. Here are the variables. Your micro O is your magnetic permeability. There's the formula for that. R is your planetary core radius, of course pi, and then the Q here is uniform electrical conductivity. T is the time it takes any given field to decay, 36.8% of any given value. And here's two formulas to determine that, but those are also measured and given in Dr. Humphrey's charge for all the planets. Time after creation. So a time after creation, 1980 will come to 5983 years after creation, and then the final value, which would be the planet's magnetic moment at a time after creation, and this is the formula. The MC stands for the pre-calculated value for the beginning, for when the planet was first created. Note that the T and M calculated values produce a model are 100% accurate compared to the measured. Okay, 100% accurate here. All right, so the B&H theory, predicting the Gauss strength of the magnetosphere of any planet, is 100% accurate 100% of the time. Note that magnetic Earth rocks of great mass do not add any appreciable force to the aggregate Gauss strength, the collective Gauss strength, the sum of the Gauss strength about the planet, and is therefore not considered in the formula, as can be concluded based on the predictive accuracy of the formula. Otherwise, the formula would not work, obviously. And this is one of the biggest points the secular scientists want to say why this formula doesn't work, because you don't consider that. Well, if it's 100% accurate of the measured strength, obviously they do not make the difference. All right, here are the calculations for the past several decades to show how predictive the model is when compared to the measured values at the time. Every now and then, for the past several decades, NASA comes out with a prediction that the Earth's magnetic poles will be reversing very soon, based on the extremely accelerated decay rate at shifting geological locations, and is disappointed every time. So, as we stated, if this dynamo theory were true, that sine wave would be very horizontal. But because it's not, NASA's like, okay, why isn't it? And they're saying because they look back at the archaeomagnetic properties and they can see reversals in the rocks, and they're saying they believe that the north-south poles reversed at times through the billions of years of history, and that's what's happening here. That's an indication it's getting ready to reverse. Not so. Not so. They've been coming out for several decades now. Every decade, so it's going to happen soon. It's going to happen soon, and it never does. And yet, it's perfectly fit with Dr. Humphrey's predictions. The strength and the measured and the calculated are within 98%. So here's a comparison back from 1835, when we very first started doing the measurements. It was within 99.18% of the calculated to the measured. In 1965, it was 99.17% from the calculated to the measured. And in 1985, it was 99.8% to the measured to the calculated. Now these are decades apart. These are 2 decades here, several decades here, and several decades here. 2010, 129%, which was well within plus or minus percent. It's a dynamic measurement compared to a linear measurement calculation. So it's going to be dynamic. It's going to float above and below it because it is dynamic. That sine wave is what you're looking at here. So this is showing the sine wave, which is what we would predict. All right, so this is just unquestionable. This is science at its best. This is the scientific method. You have a hypothesis, you formulate a formula, and then you have a what they call a control group, which would be the Earth, because the Earth is the one planet that we have lots of data, the most data. And in every single circumstance, every situation, every time, it is absolutely 100% accurate. So here are these charts that Dr. Humphreys put together for the different planets of the solar system: the Sun, Mercury, Venus, Earth, even the Moon, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. And here, these are the physical data: the mass, average radius, average density, rotational periods. Okay, so we see here Mercury uh, rotational period is every 58.82 days, compared to the Earth's, which is 24, which is every day, 24 hours a day, 24 hours in a day. All right, so that is our of course, Earth is our control group, control planet. And then here are the solar system's magnetospheres data. This is magnetic moment of creation. Of course, um, this is um, at creation is calculated. Here's the present magnetic moment, and I said I thought Mercury was wrong where I had it. That was carried over. This today it's 4.8 times 10 to the 19th, not the 22nd. It was at 22nd at the start. There. Here's the rest of them. You can see all these here are very low. So Mars, the Moon, Venus, they don't have any real. I mean, they have a magnetic force, but it's below. I think the limit is 5 times 10 to the 15th. Is that right? 18th to the 18th, where it does not have protection around it. Okay. All right, and here's the decay time we talked about is pre-recorded here. We don't have enough information on Uranus or Neptune in 1984. So those you can actually reverse since we do have um, their present magnetic moment, at least in 86 and 89, you can do a reverse the formula and determine what those decay times are. You have the core radiuses, and then you have the core conductivities. Okay. Okay, so now let's see what this looks like using graphics to graphic imaging here to make this point here. Here is the um, graph of the um, Earth here, and it's showing the decline, the degradation of the Earth's magnetosphere for the past 185 years. The first measurement started in 1835, and then we took it, well, here we took it after 10 years, and then this one was 40 years, and this was 15, and then starting here every 5 years until we got down here, and then we have a 10-year jump. And so here's what it looks like between the calculated uh, based on the B&H theory, based on Humphrey's model, the calculations, and here is the actual measured magnetic moment, okay, that we were previously reviewed. So we can show them for a comparison down through the time. Okay, and you can see that most of these are within 2%. Okay, anything greater than 95 is great. Is good science. So this right here, the section that goes every 5 years, because the increments are exactly 5 years, shows very straight line. Well, the whole thing would show straight line. We have this area first because of all the different time segments, and then if we would back these points out to where they were equal to the time, you would see that this actually is a straight line all the way back. And the same up here at the minute. So we're going every 5 years, and also we take it 10 years. But if you bring this out to where it should have been, um, it would show a straight line. So this would be, and that's what you want to see. That's the calculated. You're going to have a straight line for the calculation. And then for the measured, we talked about earlier about the sine curve and how it would also go up and below our measured. All right, staying within that 5%. So here you see these calculations: 99 point, 3%, 99.4%, 99 point, that's practically 100%, right on the money. That would be in this area here. And then the sine wave going up and down. So this is a very good um, uh, control we see that it is 100% accurate with the time segments that we know of. Okay, perfect. And it is a 10% drop. You would not see this if the dynamo theory were true. This would be horizontal. You would see the sine wave for sure, but it would be horizontal. You would not see a 10% drop in 185 years. Okay, so here's some data. This is graph shows a 9.1% drop within 185 years. The present magnetic moment being 7.746 times 10 to the 22nd power. The Tesla uh, unit, and then the diameter of the Earth is 12,756 kilometers. Okay, so we'll see that when we compare the difference in some of the other planets. So here's take a real quick look at all the planets and all those different planets and the suns and moons, and see what we have here for issues. First off, we have the sun, and it has decayed in the last 185 years about 1%. Okay, for that big, huge sun, which is 1.3 times 10 to the 8, which is I want to say 130 million. Is that right? Times bigger than the Earth. Okay, shows a 90% drop within 185 years. And again, even though this is shown at a 45, that's because of what we're showing for measurements. That's still extreme. 1%, 1% in the last 180 years, when this sun is supposed to be how old? 4.5 billion years old. And this thing reverses. You can't say that that's because it's getting ready to reverse, because it reverses. I think it says every 20 years. It actually does reverse polarity. But the sun has a whole different composition than solid planets. So we're not getting into that. Here you have one at 21%. And what we're going to find is that these are perfectly aligned with the B&H theory, and that they are all decaying in accordance with the theory and the calculations. Here we have the magnetic moment calculated from 1835, and here we have actual measurements along that timeline, which are 96% accurate, greater than 96%. Anything greater than 95 is good science. So first off, we have our control, which is the Earth, and we're going to see that diagram and compare it to the calculated and compare to the measured. So that's our control. It's 100% accurate 100% of the time. And now here we got, and they're saying that decay rate, which is about 10%, because the poles are getting ready to switch orientation. Well, we're going to find that every single one of these, the sun, the moon, the planets, they all are decaying at a great rate compared to a short period compared to a long period. Are they all getting ready to change orientation? So it's a mark against their science. Okay, so this Mercury is decayed 21%. It's within known random samples are within 96%. And you have Venus. It's decayed over 30%. According to the calculations, and when we check it, and sure enough, it's within 95%. All right, and then we got the moon. It's decayed 40% over that period of time. 40%. Now, is that getting ready to invert as well? No. Here's the measurement. It was within almost 3% of the calculated value. Here's Mars. This is the planet we're interested in the most. It's decayed about 30%. Is it also getting ready? Well, it doesn't even, it does not have a protective force field up there. It's very weak. It's not protecting it from the cosmic rays. It's because you can see it's below the 5 times 10 to the 18th power. Okay, so we got Mars. It's within 1% accurate from what we know of that sampling. Mars may have had an atmosphere and water in the forms of rivers, lakes, and oceans, just as the Earth had has up to about AD 1523, when its magnetic moment dropped below 5 times 10 to the 18th power per the B&H theory. This is the threshold that scientists set as zero protection from solar winds, that is, cosmic rays of radiation from the sun. This would cause the loss of atmosphere and evaporation of all the surface water on Mars. Mars's atmospheric pressure is less than 1% of the Earth's today. This was probably a process that happened over several hundred years, probably 500 to 1,000 years. So it didn't just reach that point in 1523 and then boom, all the water's evaporated. No, it was definitely a process. Probably started around 2500 BC, 2500 AD. I'm sorry. Yeah, 580. Probably started around 580. Okay. So Mars's geology has layered sandstone strata. See the strata? Okay. Geology has layered sandstone strata similar to that of Earth. Immanuel Velikovsky, in his book Worlds in Collision, believes the Earth, Mars, and Venus may have converged very close to each other during the time of the flood, the Exodus, and Joshua's campaign, and notes that the volcanic activity from Santorini on Crete and Aniakchak in Alaska during the Exodus and Joshua time period. So he noticed there was definitely some seismic activity and things going on in the Earth during the Exodus and Joshua's time, which could have caused global flooding and other anomalies on both Mars and Earth relatively at the same time. He's trying to say that when Earth, Mars, and Venus converged together, that's what caused a lot of disruption on all the planets involved here and caused floodings and earthquakes and volcanic activities, all this. So I predict that when they start core drilling the Martian rocks, they will find similar magnetic polar reversals in the rocks, just like on Earth, due to catastrophic crustal movement causing eddy current moments in the inner core, resulted in electrical current flows to temporarily be disrupted. So that's where I think and so does Dr. Barnes, believes where the reversals in the rocks, the magnetic reversals in the magnetism in the rocks, was not from reversing the actual core doing reversing magnetic poles because of current flow, but because of disruption in the current flow. Okay, and we'll talk about that a little bit later, how that works. So here's an image of the Martian sandstone stratified landscape taken by NASA's Curiosity rover in 21. Oh, that was supposed to be 2021. I will correct that. NASA will be performing core drilling in hopes to find fossils for proof of life. I predict they will not find any fossils of organic phyla. Okay, here's the tracking of Jupiter. So here we have the decay rate it's just about a little less than 0.5%. Jupiter's such a big planet that a lot of the changes in the calculations, as you can see here, are very slight. And so because they're very slight, sometimes the measurements only captures it within a certain decimal points. So that's why it's got this stair look here, because it's very slow. Obviously, half of decay. Even 0.5% is way too much for 4.5 billion year old solar system. Okay. Again, we have snapshots we caught in 1984 and 1990. One was at 97%, one is 152%. Again, right spot on. Then we have this is one of the Jupiter's moons, Ganymede. Here it has declined. It's got a very strong magnetosphere, actually. As you can see, it's above the threshold there. It's declined at 16%. Is it also getting ready to reverse polarity? See, these scientists, here it is, within 1% accurate again. these scientists can say anything to the public because the public doesn't know the technical knowledge of all this. They don't know this. They don't know that there is another alternative out there that is 100% accurate. And so when they say, oh, the Earth's getting ready to switch its polarization, uh, how could it be that every single planet out there is getting ready to do the same thing? How can it be? And we know this is accurate because of the Earth's measured to calculated control group. So there's, and then in each one of them we take a random shot. No matter where we would take it, it's going to be exactly equal. You can't take this many different diverse planets, situations, times, and have it this accurate. That's science. It's in the 95% category. This is good science. There's just no way that you can argue with this. There's none. There's no way you can argue with it. Here you have Saturn, again, another huge planet. Even it has decayed 3.5%. All right, and then our random snapshot is at 90, almost 98%, just a little over 2% difference. Very good, good science. Then you have the Uranus, which is much bigger than the Earth, but a lot smaller than the Jupiter and Saturn. It's decayed at almost 6% here, and then its snapshot is at 100%, within 1%. All right. Neptune, same thing, great decay, within 1% accuracy. All right, so that's a very sure, absolute science. It's perfect science. So now that we have established that his theory, that the B&H theory is 100% accurate, it's trustworthy, we can now go forward to the next step, and the magnetosphere effect on carbon-14 dating. Okay, so let's talk about carbon-14 dating method. All living things take in carbon-12, which is C12, and carbon-14, C14 molecules from the cycle of life process. So cosmic rays entering the atmosphere produce the carbon-12 and the carbon-14 molecules that are absorbed by the plants in the process of photosynthesis. Okay, so we have a protective magnetosphere, but still the cosmic rays do get by, not as much as would be harmful to the life on the planet yet, but some still do get through. That's probably where a lot of our cancers come from. All right, so it's absorbed into the plants in the process of photosynthesis. The herbivore animals eat the plants and retain an equal amount as the plants. Carnivores eat the herbivores and retain an equal amount as the prey animals. So every living thing, the plants, the animals, everything has the same amount of carbon-14 to carbon-12 in their system while they're alive. The ratio of C14 to C12 in all living things, plants and animals, also referred to as phyla or phylum, is the same as in the atmosphere while those organisms are alive. This ratio today is about 1 carbon-14 atom, okay, to every 1 trillion carbon-12 atom. That is 1 C14 atom to every 1 trillion C12 atom. This ratio is the basis for determining the age of ancient artifacts, okay, that once were alive. When an organism dies, the amount of C12 will remain constant. It's a very stable molecule. But the amount of C14 will decrease at a predictable rate of degradation. The longer the time span an organism has been dead, the greater the ratio value becomes. Table A1 shows how the age is estimated using this ratio based on half-life. Okay, so you have the present carbon-14 would be, percent of carbon-14 remaining would be 100%. If it has 100% remaining C12, it's at 100%. That would be at a 1 to 1 trillion ratio. Number of half-lives, of course, is 0 because you're at 100%. Years dead, 0. So if you measure it and get 100, it just died within the last couple of years. Half-life, which means you would only have 50% of the original carbon-14 remaining. you would still have 100% of the carbon-12. So the measurement would be 1 carbon-14 to 2 trillion, because that's half-life. That's half. All right, which means the number of half-lives is 1. This thing has been dead 5,730 years. That's the half-life estimate of the calculated degradation of carbon-14. And then, of course, another half-life would be 1 to 4 trillion, and that would means it was dead 11,046. So anything in between that, say 3 trillion or 1 to 3 trillion, would be halfway between the 573 and 1113. You would just have to calculate the percent, so and find out how long it's been dead. So that's how carbon-14 works. Okay. In addition to determining the carbon-14 carbon-12 ratio, scientists do a further analysis based on the science of dendrochronology, counting tree rings, in areas local to the subject matter of interest to refine the date range. Local atmospheres are affected by different things. This is referred to as a step 2 carbon-14 dating method. Take, for instance, a people that eat fish for a staple. Their carbon-14 count is going to be way lower because fish come from the sea. Sea is much more protected from cosmic rays, has a lot more percentage than land animals. So that's just an example. Other areas might be more overcast most of the time, such as Scotland. So you want to make sure that you test these tree rings to further refine how long the animal or whatever that you're testing has been dead, as compared to something that lives in a desert climate. Okay, C14 dating is validated by testing samples of known age. However, they can only go back about 2,000 years, because the further back beyond that, the histories are not as well established as those prior to that. Okay, so they get their confidence for C14 dating on things that they have known ages, but they can only go back to 2,000 years. All right. As the B&H theory, as previously discussed, has already proven to be 100% accurate in calculating the measured values of the existence, strength, and decay rate of the magnetosphere about large astrological bodies. Dr. Humphreys also made predictions regarding the effect of the strength of the magnetosphere on the carbon-14 carbon-12 ratios and its influence on carbon-14 dating as you go back in time. The theory advocates that the further back in time, the stronger the Gauss strength of the magnetosphere about the Earth. In turn, this provided greater protection from the cosmic rays into the atmosphere. Not as many cosmic rays got into the atmosphere because of the strength of the magnetosphere. Much stronger as you go back further in time, because it's degrading. So if you reverse that degradation, you'll see it's much more stronger. It started out at 12 Gauss, it's down to 0.62. And so along that exponential curve there, you've got to consider the strength of the magnetosphere and its effect on the cosmic rays getting into the atmosphere and its generation of carbon-14. So it resulted in lower percentage of C14 in the carbon-14 carbon-12 ratios. These C14 C12 ratios are used to date ancient artifacts, clothes, seas, wood, as related to a particular person, place, or thing, which would give a false older date based on the current two-step C14 dating method. So what it's saying is the further back in time you go, the less that ratio between the carbon-14 and carbon-12 was less to begin with. But that is not being accounted for when they do these, when the secular scientists use carbon-14 to date something. They're assuming that all the differences between what it is today and what they're getting in the measurement is decay. And it's not decay. A portion of that would be not have been there to begin with. So its starting point would have been much less, a lot lower than it is today. They are not accounting for that. Okay, so here's a picture from NASA of the magnetic flux lines protecting the Earth from cosmic rays and solar winds from the sun. So we're being protected by these, see these flux lines, these field lines of the magnetosphere, and this is the cosmic rays coming here, but they go around us, although some do get in. As a matter of fact, this is the aurora borealis, also known as the northern lights. This is a activity of that action of the cosmic rays bouncing off the north pole up there. Okay, here's a couple different pictures showing that. It's something I would like to see. I haven't seen it yet. And then here it is from a view from the International Space Station looking down on the Earth. Isn't that cool? Okay. So we're actually seeing the results of the protection that we're getting from the magnetosphere. All right. Carbon-14 dating method is currently being touted as a much more reliable absolute dating method, which in some cases has increased the gaps between carbon-14 dates and the historical dates derived from archaeology or biblical timelines. Bible scholars are asking archaeologists to move dates of their life's work down to between 100 and 150 years to match the 1 Kings 6:1. Okay. A good example of that is the Exodus, the movie by Tim Mahoney, the Patterns of Evidence, the Exodus. That's what they're asking. They're asking them to move, asking archaeologists to move the dates of their life's works down 100, 150 to match their 1 Kings biblical timeline. And C14 dating scientists are urging archaeologists to move the datum lines of well-established typology dating methods up to as much as 120 years. So they're being archaeologists that use typology datum lines are being pulled both directions from different cultures of our world here. You know, the Bible scholars saying, "Oh, you need to move that down." And then you have the scientists for the carbon-14 say, "Oh, you need to move that up." Just so there's about a 200 years difference between carbon-14 dating and biblical timeline, and about 100 years difference between archaeology datum lines. Many archaeologists and Bible scholars alike reject the carbon-14 dating for events earlier than 1000 BC due to irreconcilable gaps between the two of any specific event or subject matter. As we see in the next few segments, applying the B&H theory pertaining to the effect that the strength of the magnetosphere about the Earth has on carbon-14 ratios has resulted in an amazing reconciliation between the well-in biblical timeline and ancient historical chronologies, and especially Egyptology. So we took the theory, the B&H theory, and especially in regards to the magnetosphere and its effect of carbon-14 dating, and we looked at the timeline, the Egyptological timeline, compared it to the well-in biblical timeline, took that theory and we made some adjustments. The B&H theory advocated that the effect would inflate the age to a significant margin of error at a calculable rate for dates earlier than 1 BC. So we said earlier, the secular scientists that are carbon-14 scientists, they can check the dating between known events up to 2,000 years. All right, but the strength of the magnetosphere up in that time is marginal. It's not significant enough to make an argument. But once you get past 1 BC, now you're going to start really seeing some differences. When you get past 1000 BC, that's when you're getting up to 50, 60, 70, 80, 100 years differences between the carbon-14 dating and archaeological dating, or actually the well-in biblical timeline. All right, it would be inflated beyond a calculable rate before the time that the ice caps and the volcanic aerosols dissipated from the environment, which creationists put it around 1800 BC. At least that may be the peak, and it's starting to decline from there, and be along an exponential curve. Okay, so that's what we're going to look at. We're going to look at that. Here's a chart showing the decay magnetosphere effect and carbon-14 dating. This is from Dr. Humphreys, and he's saying that like 1970 is 0.62 Gauss. All right, and then the effect of the strength would reduce the carbon-14 ratios by 2%. Then as further back you go, 4%, 8%, 16 to 21.6% back at the 400,000 BC. 4000 BC, I'm sorry. So this is his estimates. These are estimates by Dr. Humphreys. All right, and here it's in a table. So you got the year 80, gauge strength 0.62, 0% difference. When you get to BC 500, the gauge strength is up 2.3% stronger, and it should affect the carbon-14 by 3.4%. And then here you go. Here's the flood demarcation. You go back 2,500 years, and it should be now at the gauge strength be at 6.5 gauge, and it should be affected percent by 8% now. Okay. The greater margin of error when taking into account unknown environmental conditions affecting C14 buildup in this range here. And then the 500-year ice age after the flood would have significantly affected the environmental conditions, volcanic aerosols, and reflections off the ice. That would be beyond 1800 BC. And then unknown, before the flood, unknown effect of the antediluvian greenhouse gases and other environmental unknowns up to 6,000 years with carbon-14 estimated error. Okay, so anything before the flood is just so unpredictable. You can't trust carbon-14 at all. This is a chart and table showing error of secular science using the carbon-14 dating. Dates in parentheses, all right, in my book are indicate an adjusted date of the subject matter. Okay. So, as we have seen in the B&H theory, has already proved to be 100% accurate in calculating the measured values for the existence, strength, and decay rate of the magnetosphere about large astrological bodies, the planets, sun, moon, planetesimals. And again, as we have seen, the B&H theory also made predictions regarding the effect of the strength of the magnetosphere on the carbon-14, carbon-12 ratios and its influence on C14 dating as you go back in time. All of the material from creationists and Bible scholars appear to neglect taking this science into consideration when dating historical events, consequently failing to make the necessary alignment, synchronizations of time periods for the biblical chronologies with the secular chronologies. This has been the contention of most historians that biblical chronology does not align with secular chronologies. And this is the reason for it, according to the B&H theory. Secular scientists are not considering the empirical evidence that shows that the strength of the Earth's magnetosphere has declined significantly in the past couple centuries, and therefore should be considering the probability that its decline has been steady for several millennia. This decline would have had a drastic effect on the carbon-14, carbon-12 ratios on which carbon dating the age of organic matter is based. The further back in time, the greater the strength of the magnetic gauge forces about the Earth and planets. The greater the strength of the gauge forces, the greater the protection from incoming cosmic rays that vegetation takes in via photosynthesis at equal amounts of carbon-14 and carbon-12 that is in the atmosphere. The greater the protection, the less C14 buildup in the phylum of the time. In other words, much less C14 percentage in the ratio to start with. This deficiency in the carbon-14, carbon-12 ratio can easily be mistaken as decay when in truth it was not there to begin with. So they're adding decay time to something that had not decayed at all to that starting point. Based on the B&H theory, control dates can be established by finding dates where the biblical timeline is congruent with the archaeologist's typology that can be used to calibrate the C14 dates. Typology includes pottery serrations and recurrent architectural features such as building materials, house types, tomb types, plus a combination of all of them. This is BTEC 2013, page 78. He was the man for BTEC was the archaeologist over Avaris or Goshen, where the children of Israel were enslaved right there at the delta of Egypt. With these control dates, a coherent timeline for the C14 dates can be developed that reveals the patterns of evidence, okay, the best fit curve of the carbon-14 decay that align with the B&H theory of the effect of the magnetosphere on the C14, C12 ratios. Okay. So these decay carbon-14 dates can then be adjusted based on the control or calibration dates to match the biblical timeline. Remember, the 3 points that we found that exactly match the Wallen biblical timeline in archaeology, the start and end of Avaris and the fall of Jericho. Well, those are solid dates now. They validate each other, and we can use them to begin our process of determining the difference in the carbon-14 dates, that deficiency we were talking about. Okay, if the theory is sound, this should reveal patterns of evidence between the biblical timeline and historical events and the secular chronologies as proof of concept. All right, so you have the hypothesis, you have the testing. We're going to test it now. Proof of concept is that you'll have patterns of evidence between the biblical timeline and historical events when we adjust the historical events to match the timeline based on our calculations, okay, that we're getting ready to do here, especially where Israel and Egypt's history intertwine. And as we just see, it very well does, okay? There are 3 dates in archaeology based on typology dating method that are congruent with the Wallen biblical timeline dates within acceptable margins of error as follows. And we talked about this earlier. The fall of Jericho is the first, at the end of Avaris' first occupation, and the start of our Avaris' first occupation, and how they're spot on, complementing one another, validating one another. And here's the references for all this. I got all this information, okay. So this is archaeology matching the Wallen biblical timeline. 3 solid points. I designated these as my control dates. Always got to have a control. You always got to have control dates. Control science. In science, you always got to have controls, okay? And later on, when we start talking about other sciences, we'll see where the secular scientists fail to get the controls. They're control groups. All right, so I designated these as my control dates because they were dates that both the Wallen biblical timeline and the archaeological dates were in close agreement. Next, I searched for carbon-14 dating of these 3 periods in history. Okay, so now we're going to carbon-14 dating. We have the Wallen biblical timeline, archaeology matching correctly. Now we're going to see the difference in carbon-14 datings of those 3 points. Control date 1. There is a review of the Jericho site in the Associates of Biblical Research website that gives all of the C14 tests done from 1993 to 2000. A high-density model was formulated to derive an average date for the destruction layer of Jericho as identified by archaeologist Kathleen Kenyon. So Kathleen Kenyon is the one that established these archaeological date of that layer, the destruction layer of Jericho. All right, and then when we talk about a high density model, we're talking about high density of the data. So we're going to look at all the data and everything that creates a little clump. We're going to count as valid test results. Anything outside of the clump data is going to be disregarded. That's what they call high density modeling. So the actual biblical timeline, Wallen biblical timeline of the destruction of Jericho is about 1512 BC. Kathleen Kenyon dated the site at 1550 BC using typology datum lines, which is within a reasonable margin of error with the Wallen biblical timeline, data 1512. Average ratio looks like it's within 99%. The average results from the highest density modeling of the carbon-14 testing of Jericho site comes to 1596 BC. See our figure 1. So you see here is the test dates, 1993. These are all AD dates, obviously. 1993, 1995, 1995, 1995, 1995, 2000, 2000. Here's the results, the carbon-14 dating 1590, 1527, 1640, 1520, 1690, 1610, 1597, and 1347. So you'll see that we determine our high density range in here. Here is our average date. So here's the upper threshold of those dates, that data, and here's the lower threshold. And as you can see, we have this one it's outside of the high density modeling. And then we have our average date. Our average date came to 1596, and we can see that that's quite a bit of difference between the 1512 and the 1596. So there we go. That is for the Jericho site. Okay. Control dates 2 and 3 now, which were the start and the finish of Iris, or Goshen as we know it from the Bible. Next, data needed for carbon-14 dates for the occupation of Aris were found in a couple of papers written by Hofmeyr in 2015 titled Carbone-14 Compare. He's a French archaeologist. And ResearchGate Radiocarbon 54 3-4, pages 407 to 422. Using the average dates from high density modeling HDM for the start and the end of the first occupation of Avaris, I came up with the following control or calibration C14 dates. Control date 2, the end of the occupation at 1661, was the average date from the high density modeling of the carbon-14 tests that were taken at that time, the first occupation of Avaris, and then that was the end, and then the start, we came up with 1893. Okay, so now we have our average dates from high density modeling for the three control dates. Okay, so with this data, I drew a graph between these points for a best fit curve between the Jericho C14 date and the C14 date of Joseph's appointment to Treasurer of Egypt, based on the start of the occupation of Avaris, along a timeline based on 50-year increments starting from 1500 BC to 1750 BC. These are my core dates for the C14 offset against the Walling biblical timeline. So as you can see here, this is the best fit curve from 1500 BC to 1750 BC using 50-year increments. So 1500 BC, you could just make out the control dates, which is here 1, 2, and 6 are my control items, control dates. And then we did a best fit curve from 1 to 6. And as you can see, it gets a little bit off here. And the reason for that, we found there's a little glitch. This actually goes like this and then goes glitch and then comes back because of the environmental conditions at the time of the Exodus. There was the volcano, one of the largest, I think, volcano that they know of on Santorini. And it had these aerosols in the air for quite a while, and it caused a little glitch. It barred the cosmic rays for a little bit, causing the carbon-14 to be a little offset at that point. And that shows up in history. A lot of secular scientists acknowledge that, actually. So we have our control dates 1 and 2, and then 6. So we drew a best fit curve in between them, and then we went to the next step. So here in the next step, I then extrapolated dates to extend back to 1000 BC and forward to the start of Ahamen's rule as the first pharaoh of Egypt. We have that date as 3100 BC, that carbon-14 date, and from my core dates along a best fit curve. Okay, so we just basically, here are my control dates here, and this constitutes my control core dates, and then I just extended it out to Ahamen's rule at 3100 BC here in 50-year increments, and then I extended it all the way back to 1000 BC, and these are all 50-year increments along there. Okay, so I just extrapolated those dates from my core dates. And then I extrapolated the C14 dates to extend to the time of the flood along the best fit curve alongside the corresponding biblical timeline dates. Okay, so the blue represents the biblical timeline, and the extrapolated C14 dates are the orange. And as you can see, once we get past a certain point around 1800 BC, it does start, according, just like it was predicted in the B&H theory, it starts getting exponentially out of whack here. Okay, so anything before 1800 BC is not a reliable. There's no calculable way. I mean, we can get some rough qualitative, but nothing quantitative. Okay, but it definitely can help us do some qualitative adjustments. Okay. So here is the biblical timeline compared to associated inflated C14 dates along the best fit curve. You have the year 1000 BC. The percent average is about 1.56% greater, so you'll get a carbon 14 date of 1047. Okay, as you go along, here are control 1, 2, and 3 dates. There was the control 3 at our Walling Biblical Timeline date at 1750. The carbon 14 date is increased by 3%, and you'll get a carbon 14 date of 1863. It's 1635 and 1581, and then the rest of these dates you can see are increased as you go back exponentially. Okay, so this is the key. This is the key here. So, being that Egyptology is the premier historical references, chronologies that all historians, no matter what they're into, whether it's Assyrian, Babylonian, Palestinian, they all have to figure out how to match up to the Egyptian chronologies. And Egyptian chronologies, for the most part, are based on carbon 14 dating. Okay, we're not talking about archaeology here. We're talking about Egyptology. Two different things. All right, archaeology and Egyptology conflict, biblical timeline, and Egyptology conflict. The biblical timeline and archaeology agree together, and that's what these dates are based on. All right, and the difference can now be calculated. Here we go. We can calculate in dates in between. These dates can be interpolated. Okay, so if this is halfway here, say this is 1825, you just take the 50% of the time between these two, and that would be the coinciding date. Okay, so you can do a direct interpolation. It's not going to make that much difference, even though it is on a bit of a curve, but not so much that it makes a difference. Sure enough, the best fit data appears to align with the B&H theory, except when I went to check it against their specific values. Remember, he gave us specific values along that curve that they would be affected. The percent effect on the carbon 14 carbon 12 ratios, I found they were not congruent. So in this one respect, they were not congruent. The other three items were spot on, but the actual percentage he was off. I found they were not congruent. We can look at that. Look at table B2 with Humphrey's prediction. All right, so here's table B2. Here's the gauge strength that he predicted. Here's the percent of carbon 14. Here's the difference that he's saying it would be affected by, and what the BC date would be compared to the based on the percent differences. Okay, so he was wrong here. Doesn't match up to mine. Here's mine. Then I developed a revised chart based on the evaluation, the data I evaluated. And this is the same chart I showed you, only this has to do with the percent effect on the carbon 14 to carbon 12, that's rather than the percent difference between the time. So here's the differences. Like for instance, in the year 1000, you would get that at 69.56. If you did some testing, it's off by a little over 0.5%. So you adjust it by that 0.5%, and this is what it would really be. And then your age is it would be that many years old from 2000, and then you adjust it for a BC date of 1047. So 1000 BC would actually come up with a date of 10,047, and so forth as you go down the line. And this is on a curve and an exponential curve when you get down here. Here's the actual formula and a sample calculation calculating age based on percent C14. So there's the formula. There are the variables based on a half-life of carbon-14. That percent would give you 301 years from 2000 AD, which would be at 1001 BC date from 2000 AD. Okay, so then you have what I have concluded here. In the end, I extended the timeline back to the birth of Christ for future research by myself and other historians wishing to apply these adjusted historical dates. So there it is. This is the chart. This is the table that you would use for, and you could apply this to any historical chronologies. Like I said, all historical chronologies have to match up to Egyptology. That's just the way it is in the scientific world. And then Egyptology, since it is based on carbon-14 dating, and that's what this chart evaluated. And I've already tested it. You can take any dates in any historical chronology, adjust them according to this. So let's say you got a date. The date itself says that this king rose in the throne in 1309. The actual date will be 1250 BC. So you have one that rose to power in 1747. It was actually 1650. And when you do that, and you look at evidence and look at patterns of evidence and things that have happened in events that have happened in their let's say their period of reign, it's possible you could find some patterns of evidence that do fit the biblical timeline if there was any reaction between the Hebrews and their empires. All right. In this first test, I found that the B&H theory for the magnetic sphere inflation of the carbon-14 dates was spot on in that the carbon-14 dates were inflated, calculable, ever increasing on an exponential curve, and excessively inflated for dates earlier in 1800 BC, just like the B&H theory predicted. Perfect. Okay, the only thing that was not in alignment was, of course, his predictions on what the percent difference would be. All right, in my continuing query, I came across a mother lode of data in an article of ResearchGate, again, titled Radiocarbon-Based Chronologies of Dynastic Egypt. So here it is. This is beautiful. Here is some carbon dating that hadn't been done in ages. It's been a problem with historians not being able to have carbon-14 dating to validate or invalidate their theories. Immanuel Velikovsky was one of the major historians that would have loved to have this data that he didn't have. This article has a table with the latest and greatest two-step carbon-14 tests performed on Egyptian pharaoh artifacts for some of the major pharaohs. Of the Old Kingdom, Middle Kingdom, and the New Kingdom. Each pharaoh has two carbon-14 date ranges that were calculated based on the high posterity density range in the Bayesian model at 65% high density posterity and 95% HPD, both coming out very close to each other. Okay, to further test Humphrey's theory, data was extracted from the article and entered into an Excel spreadsheet. The table was then modified with 4 more columns. So we have this table that this radiocarbon-based chronology for the dynasties gave us, and it had several columns in there. 2 of them were these high-density carbon-14 tests, so they gave us ranges at a 65% density and a 95% high density. Okay, and then so I took it and developed a spreadsheet. I put in several more columns. 4 more columns. The first one is the Wallen Biblical Timeline. Okay, and these are my references here, my sources where I got that from. The Wallen Biblical Timeline, the B&H theory, magnetosphere carbon-14 inflation percent based on the strength of the magnetosphere that comes from my table, and effects on the carbon-14 buildup in phyla at the time period of interest, source from Wallen's revised table B3. The MP carbon-14 inflation date, okay, so you have my date, the Wallen Biblical Timeline date, the percent difference at that time, at certain times, at whatever time we're talking about, and then the adjusted date, okay? And then the average carbon-14 test dates for the available data, which were not given in the table. They just gave us ranges. I had another column made to give these dates an average. And additionally, I created a row was added to each pharaoh to show the average dates of the HPD analysis. Okay. All right. So the first, the average dates of the two HPD ranges were calculated. Then the dates of known events from the Wallen Biblical Timeline were entered into the spreadsheet under the Wallen Biblical Timeline column, such as the fall of Jericho, the Exodus, Israel's entry into Egypt, etc. For each of those entries, the magnetosphere carbon-14 inflation percentage was entered from the above revised Walling C14 table. Okay, so the carbon-14 date for those periods were put in there. This is the estimated carbon-14, the date based on my table. Okay, not the actual tests. Then the calculated inflated date for that event was entered. The end results found that the dates of known biblical events, Exodus, Moses' birth, Israel into Egypt, and many, many more, later than 1800 BC, aligned congruent within acceptable margins of error with events found in each of the Egyptological pharaonic dynasties. See Chapter 3 for discovery details. Table B4 below is a summary of the data and supporting graphs. Okay, so you have Jericho. Okay, the Wallen Biblical Timeline says the Jericho event happened in 1512. We found the inflated date, which of course Jericho is one of our control dates. So we found that the inflated date was around 1593 when we put a best fit curve in there, and the actual carbon-14 dates of that time. So this is the predicted date that it would have based on my timeline, and this is the actual date. So close. And then of course Exodus 1552, another control date. We had that. It was found to be 1661, and the actual date of the Exodus, and this is based on the Pharaoh that we found of the Exodus, and his end date of his reign was 1661. Perfect match there. Moses was 1632 was when he was born. The inflated date based on the table would have been 1725, and the actual carbon-14 average dates down to 1730. Remember too that these are average dates. Really these are done in ranges. I just want to do an average to see how close, how accurate this would be, and how accurate those high density models are. And it looks pretty accurate. So Israel into Egypt, 1767, inflated date 1882, actual date comes out to 1868. Josephus, number 2, as the number 2 under the Pharaoh, 1777. Inflated date 1893, actual date 1889. The Josephus in Egypt, 1790. And these dates are based on the Pharaoh's times that we identified, each that aligned with these dates. We took these pharaohs, see if there were some patterns of evidence, which there was tremendous magnitude of evidence there, and used their dates, approximate dates. Okay, so Joseph into Egypt came in at the Wallen Biblical Timeline 1790. The inflated date was 1911, and the actual carbon-14 date average was 1881. Now here's where we're beyond. Obviously, this is close to 1800s, which is going to start to affect the difference between these dates. Again, anything beyond 1800, and a little bit into here is going to be affected by the environmental conditions that are including the magnitude of the force of the magnetosphere, but also other things. So, but here these dates are just based on both of them on the carbon-14 kind of dates that were given, because we couldn't estimate these like we did these. Okay, so we got Sodom and Gomorrah happened in 1936. The approximate qualitative date, inflated date, was 2180, and of course we got 2181 for the actual carbon-14 dates of what we think is related to Sodom and Gomorrah. Same thing for Alhamenes. This is carbon dated 3100 BC. We have our inflated data along that best fit curve at around 3133 qualitatively, not quantitatively. Okay, so that's incredible. Here's what that looks like when you do it along a graph. You have the C14 dates in blue. That's the actual C14 dates. The magnetosphere inflated dates taken from our graph, almost a perfect fit, and the Wallen biblical timeline dates in the gray. So that shows the difference between the inflation of the carbon-14 compared to the Wallen biblical timeline. Okay, so here's that Excel spreadsheet that I talked about earlier from the article with the mother lode of carbon-14 date ranges. All right, so the original columns were the number of carbon-14 samples. These are two Egyptologists, Shaw and Hornung, and then the 65% HPD modeling that we talk about here is the from and the to dates, the range, and the 95% HPD from and to dates. Okay, and then I added another column, the Walling biblical timeline, all right, here, and then the BNH MP carbon-14 inflated percent in this column, and then the magnetosphere's carbon-14 inflated date here based on these percents. Okay, and then we added also another row to all of the given pharaohs, and we averaged those HPD, 65 HP and 95 HPD dates to get our average. So here, this range here, for instance, is a 65% HPD. was from 1922 to 1901. That averages to 1912. The 95% HPD from 1928 to 1876 averages to 1903. And then I take those two and average to get an average date, an average carbon-14 date for that pharaoh. Okay, and that would be based on the start of these are on the start of their reigns here. So they Egyptologists, Shaw believes that this Amenhotep II started his reign in 1911. Hornung believes it's more like 1878, but our carbon-14 date is at 907. And then, we take, and in this area, you got to remember this is prior to 1800 BC, okay, according to our Wallen biblical timeline. So things are not going to be as calculable in this area due to environmental conditions such as aerosols from volcanoes, the reflection off of the ice during the ice age, that kind of thing. All right, so we have concluded that our up in this area we actually went mostly with coming out of these more sure dates using the actual rain date. So if this rain was 15 years, we went from I'm not sure. Yes. So we would have took 1766 and added 15 years to come up with this date here. So, all right. So that's how that worked out up in this area to get more accuracy out of it. And then we did the inflation percent to get a more qualitative date. So this, for instance, Amenemhat II, we came up with an 1860 date based on this process. That would have been inflated about 3.2. We're in the exponential curve. We're before the 1800s, so it's just unpredictable. We're going to get a qualitative date of it about 1938 compared to our average date of 1907. Still pretty good. Still pretty good average, pretty good margin of error. And as you can see, it is very close to being within our ranges, as a matter of fact. And you really got to look at the ranges is what you really got to do mostly here. So anyway, so we go on along here and we see that Joseph entered Egypt at 17 years old. That was in 1790, inflated date 1911. All right, and that looks like it was almost 10 years prior to Sennacherib II being starting his reign. Okay, which was started in 1781 according to our calculations, and that they give it a inflated date of about, I'm sorry, they give it a carbon 14 date of about 1874. I didn't do an inflation thing. I wish I should have, but anyway. So, but we know that Joseph was elevated to the second ruler at the age of 30, which would have been 1777, and that is again an inflated date of about 1893 when we apply our percentage there. Okay, and so that would have been you know very close to that 1800 BC where the conditions atmosphere would be throwing that off a little bit. So we can see that it's not a quite perfect match there. It's not bad though. It actually is within the date range of 1895. And you got to remember, this is when he started, and he elevated. It looks like he elevated Joseph about 4 years later after he became king. So those dates, are not too bad. Once you get in this qualitative area, and that's what we're looking at, qualitative. And we know that that was pretty well established for Sennacherib because he had 40 samples of carbon-14 dating, which averaged to 1889, okay, start date, which is rejected by BTEC. Okay, I'm sorry. This is not Sennacherib. This actually is the start of the Goshen, the avarice, the start of the occupation of avarice, okay, which is rejected by BTEC based on typology datum lines. We've been through this, that it was about 120 years off. The inflated, so the MP inflated date was about 1893, very close. Now we're starting to get some very close dating here, and of course, well, that's one of our control dates, so that's why that is so close. All right, to be honest. So Joseph, so what's the first thing? Joseph is elevated in 1777. What's the first thing he's going to do? He is responsible for growing crops in abundance for the next 7 years to be able to supply Egypt, actually, and Canaan. He had so much overabundance. So how do you do that? Well, he starts. Sennacherib II is famous for building canals throughout the delta. And that's exactly what Joseph would do. He would start digging canals for irrigation, and that's what it was for. It wasn't for navigation or any other purpose, according to the Egyptologists. So this is a very good reflection of the synchronization between the Bible and the Egyptology. Bam! We started off. Hit the ground running here. All right. So then the end of plenty came in about 1770. And then Israel came into Egypt when Joseph was about 40 years old in 1767. And then about a year later, Sennacherib III became king behind Sennacherib II. And you can see that the inflation date and the I'm sorry, the inflated date for Sennacherib III and the actual average date is not too bad here. Okay, definitely falls well within the ranges. All right, and that's the important thing. It's really starting to hone up now that were getting away from the 1800 time. And then you had the end of the famine. All right, so Sennacherib III, he is famous for a lot of things that do align with uh, you know, Joseph in the Bible at this time. So let's just read some of his accolades here. He built a chain of forts to secure a new fixed southern border. Fundamental changes during his reign in material culture and in administration. Well, Joseph's in charge. Basically, the Pharaoh gave him full command, let him do what he wanted to do. I'm sure he was opposed to idolatry, and he probably instituted some changes on administrative level. Major overhaul of burial customs, end of the custom of writing extensive rituals and other funerary literature on coffins. The country, now this is key right here, the country became more centralized. The provincial centers declined in importance. The fameless region around the residence of the kings grew in scale and wealth, just like the Bible describes. So there's so much reflected in Sennacherib's accolades and his reign that really align just beautifully with the Bible. So now we really are looking at some proof of concept here about our theory. Okay. All right. So you have the Joseph dies at 110 years old in 1697, and actually at this time, the about this time the 13th dynasty arises. Okay, and the Bible says this is a period where a pharaoh arose that did not know Joseph. So it was right here at this timing, the 13th, 12th dynasty coming to an end, the 13th dynasty arising. Okay, so very interesting. We're going to expand on that on the next lesson. Get really into that, how well synchronized that is along with the 14th dynasty. Okay, so again, now we're looking at several, the 14th dynasty, the 13th dynasty, 14th dynasty, both starting up after Joseph's death, after the end of the 12th dynasty. And the 14th dynasty was contemporary with the 13th dynasty, predominantly not pharaohs. No cartouche normally associated with these rulers. They were Semitic rulers. They were overlords appointed by the pharaoh from the 13th dynasty to oversee taskmasters to execute his commands. Okay, these were vassals in Avaris in Goshen. This was just a vassal province that were appointed by the 13th dynasty's pharaohs. All right, some of the overlords may have been Hebrew sycophants that sought profit, privilege over allegiance. Manford B. Tech dates the occupation of Avaris, Eldab by Semitic peoples from 1783 to 1550, 233 years, congruent with the biblical record. So we're looking at a lot of synchronizations that are just outstanding. How do you have this many lines? And then let's talk about Menford A. My goodness. All right. So this is the Pharaoh of the Exodus, no doubt. If you recall, the 1661 date at the end of his reign is absolutely exact match of the average carbon 14 date of the end of Avaris, 1661. So that's how we identified him. And not only was that, but there were so many more patterns of evidence in his reign that there's no doubt about this is the Pharaoh of the Exodus. So let's read some of his accolades. In spite of his long reign, the number of artifacts attributed to him is comparatively small. This may point to problems in Egypt at the time. This is a quote from the Egyptologist. He's acknowledging that he was so preoccupied with the increasing uh, of the Hebrews, the population of Hebrews, and taking up his army and the efforts of his army and all. He didn't have time to go out and expand his his territories and all this like many other kings. Okay, and indeed, here's the kicker. And indeed, by the end of his reign, the administration of the Egyptian state seems to have completely collapsed. All right. Well, if you take the death angel that comes to kill the firstborn males of Egypt, well, in Egypt at this time, if you're appointed to an administrative office, you're appointed for life. And when you pass away, your eldest son, your firstborn son, takes your place. So if you're going to kill the firstborn sons of Egypt, you're going to devastate the administration of Egypt. Okay, so let me read it again. Indeed, by the end of his reign, the administration of the Egyptian state seems to have completely collapsed. This was the end of his reign. This was the end of the 12th dynasty, and this was the end of the Middle Kingdom. Major, major, major collapse. It is possible that the capital of Egypt since the early Middle Kingdom, Itawa, was abandoned during or shortly after A's reign. For this reason, some scholars considered Menepher A to be the last pharaoh of the Middle Kingdom of Egypt. So we can go on and on and on about some of the proof of concepts that come out of this matchup. It's dozens and dozens and dozens. You can't that is proof of concept. That is the scientific method. You have a theory, you apply the theory, and then you look for the proof of concept. No other timeline has this magnitude, perfect magnitude of proof of concept. So the next session we go into, I go into that, and I dissect all of these pharaohs, all of these events, and what happened, and what the corresponding proof of evidence in the reign, including here in Menpher A's, his visor, his number one visor, was actually the firstborn son of the previous visor, and he died for unknown reasons. He just up and died. In the Egyptologists acknowledge he was number one. He was the firstborn. Number two, he was the top administrator, Menepher A's top administrator, the visor, and he died of unknown reasons for unknown reasons. Perfectly match what the Bible says. Of course, you're going to have a collapse of the administration when you start killing firstborn. Menepher A's firstborn son was killed, and so was the visor. It's pretty evident that when you find this kind of events that happen out of a synchronization with the Bible, then you have to acknowledge, especially when they start to build up, since when each and every one of these coincide exactly what the Bible says, you really got to take it serious. So that's the end of this session. Let's hope that you'll return with me to the next chapter, which we will get into all these incredible proof of concepts. All right, so I just want to point out a couple more things that I overlooked a little bit on the last session there. I want to talk about this carbon 14 sampling. You can see that not every one of these pharaohs have a sampling because not all of them have articles that you can sample, but and there's a lot more pharaohs in between these that I'm not showing that probably do have samplings as well. So they're just laced here, which is a very acceptable scientific method. So you have all these intervals between the different pharaohs, and if when you take samples, random samples laced throughout it, and they come up pretty accurate, then you know that you've got a good science here. You've got a good sequence here going here. So they did a good job. The secular scientists did a good job at getting the intervals down and in all the right places for the most part. Um, so the only thing is that of course their carbon 14 dates are off. So that's what we did to adjust them. So other than that, they did a good job at listing them and chronologically and their ranges and all that. So the other thing I want to show is this little glitch here we talked about earlier. We know that Menepher A dates is from secular date is from 1684 to 1661, and as we have repeatedly say, these dates are supported by carbon 14 dating. Okay, and even if they are accounted for by the laces. Okay, so we know that we had a perfect match between Menifer A's end date and the carbon-14 dating of the end of a virus, both of them 1661 BC. So that was a perfect match. And of course, we would have adjusted those based on the offset at 1552. And as we just mentioned earlier, right about the time of the Exodus, there was a little glitch in the carbon-14 dating by about 30 years or so, maybe a little less. But so we're showing inflated at 1637. So what happened is there was that volcano that went off on the island of Santorini. It was probably one of the worst volcanoes that we know of. It wiped out the Minoans, put a major aerosols in the air for years to come, and it affected the carbon-14 dating. It blocked the carbon-14 dating, so you got a greater age by about a little bit less than 30 years, and that's the glitch that we're seeing here. All right, the other thing that I want to show is the accuracy of the timeline here based on these average dates and all that. So we kind of did the same thing here as we did up here with the pharaohs. So anything that's in the yellow here are dates that we are sure of. They're from the biblical timeline, from the biblical characters. So we did the percent offset and all that. But we did the same thing here to as much as possible, but dates, using actual rain dates to better establish where they fall in the biblical timeline. Okay, and then we took the inflated carbon 14% and then found out the carbon 14 inflated date. All right, and as you can see, like here, this how close is this to the average? I mean, look at this. This is how we are proving both ways, proving the Egyptian timeline and the Wallen biblical timeline by cross valuing these things, calculating. So here we go. So here we got 1672 is what we come up when we did some difference in these rains. Like here, it's the 9 years difference. So that's where we come up with that. We applied our Barnes and Humphreys and C14 inflated percent, came up with 1774, and look at the average date for this Sobek and Farouk, 1775 average date. Wow, I don't think and here this one's right on the money. So 1681 inflates to 1784 on our predictive curve, and 1774 was the average date. Okay. What do we got up here? We got Sennacherib, 1766, inflated date 1881, and the actual carbon-14 average 1867. So this is really another variable, another element to the proof of concept of our adjusting these dates. Really cool stuff, man. It's just a three-chord three-chord what is it called? Three-strand chords. It's just really strong here. It's just really strong in that when we go from our dates this way, we find them. When we look at the Egyptologist dates and we use them, it comes up the same as well. And then, of course, the proof of concepts that's coming out of it. I mean, this is really a really good scientific evaluation. First time ever that this has been done.